Hi class, we are going to be dealing with 10.1 today, or learning 1. And 10.1 is the law of sines. So we're furthering our trigonometry lessons. And remember, trigonometry is just the measure of triangles, studying the measure of triangles. It's all about the measures of triangles, which each triangle has 3 angle measures and 3 side measures. So trigon is a Greek term for triangles, and metron is a Greek term for measure, and so together trigonometry means measuring the measure of triangles. Now, the law of sines is something we can use when triangles don't have a right angle. So if the triangles don't have a right angle and we still want to figure out a side measure and or an angle measure, we cannot use the traditional sine, cosine, and tangent as they are because they relate sides and angles of right triangles together. So the law of sines is there for us when we don't have a right angle. So what it says is, notice that in these triangles, the angle A, let's see if I can come up with the pen here, and it doesn't move on me. Woohoo, it didn't move. So this angle A, its side opposite is little a. This angle C here, its side opposite is little c, measure little c, and then side B here, opposite it is little b. So when you have an angle B and a side B, they're related in that one's capital, one's lowercase, but they're the same letter for angles opposite sides. The law of sines says that if I take the sine of big A, that means angle A, and remember that angles always follow the sine. Sine of big A over little a, the side measure A, that will be equal to the sine of angle B over the side little b, and the ratio of the sine of C, sine of angle C over the side opposite its measure little c. Those are all equal to each other. So that relates each sine of an angle over a side that's opposite. Now notice that with these we have a lot of options. We have we could use angle A, we can use angle B, we can use angle C, we could use side A, side B, side C. And if we want or need an equation to figure out a side or an angle measure, what we could do is we could take any of the two. We don't have to do all 3. We can just come up with 2 for which we have 3 of the 4 variables. Okay, that means 2 angles and a side or 2 sides and an angle. Then we can relate it, and then we can set up an equation that we could use to solve for either of the angles or the sides. So if I had, say I know this angle right here is 40, and I know this angle right here is, I don't know, 50. That would make a right triangle. 52, okay? And I know this side is 12, and I don't know this side, I could actually solve for this side. What I need to see is, do I have an angle and the side opposite? Which I do. I have an angle but not the side opposite, and that's fine because I have sine 40 over 12 is going to be equal to, let's do that a little bit over, sine 40 over 12 is going to be equal to sine 52 over x. All right, and that gives me, sine 40 is just a number, sine 52 is just a number, 12 is a number. I can cross multiply and solve, and then I can come up with my unknown right here, this side b, which we're going to call x. And that's what it's used for. It's used to find missing measures of triangles, and in particular, triangles that are not right. Now, you can use it for right angles, that's fine. But that's usually not necessary because you can just use the normal sine, cosine, and tangent, which are far less complicated and much easier to use than this. All right? So what I do, I look and see, well, what do I have here? So I have this angle, and I have this side and this side, and those are all either an x or a number. And I have 3 of the 4 across the 52 and across the 34. I have everything set up just like I need it, which is very nice. right? I mean, that is very nice that we have all that, so we can use it. So what we do is we take the sine of 34. Now, that's pretty simple because all we have to remember is the sine of the angle over the side measure opposite. So we just take up sine 34 over 10. Then you don't have to remember A, B's, and C's and whatnot. Just note that it is the sine of the angle over the side measure that is opposite that angle. That's going to be equal to sine 52 over x. Okay, so just take a look, make sure that everything is set up correctly. You have the sine of the angle over the opposite side, side of the angle over the opposite side, and you have all your measures except one so that you can actually find the one you're missing, and then you just cross multiply and solve. Now, always remember, sine 34 or sine of anything is a number. It's just a number. It's a decimal, it's an irrational number, but it's just a number. And same with sine 52, it's just a number. So when you look at that, don't think it's a bunch of variables because it looks like it. It's not, it's just numbers. But you can cross multiply. So you have x times the sine of 34 is equal to 10 times the sine of 52. Now it's better if you put the x and the 10 in front of the sine when they're multiplying as adverse to after the sign, just because it helps keep the numbers separate. So we have x, a variable that they were solving for, times a number is equal to 10 times a number. And that's easy to solve. We want to solve for x. It's being multiplied by sine 34. So we're going to divide by sine 34 so that we can get rid of that sine 34 and have x equals 10 sine 52 degrees over sine 34 degrees. All right, then use your calculator. Make sure you're in degrees, not radians. Use your N over D button as much as possible. If you haven't gone to Target or Walmart or Staples or somewhere and gotten yourself one of these calculators from school, then I would right now go and do that because you're going to need the N over D button and your sine, cosine, and tangent functions. So that's over sine 34. All right, and if you hit enter, you have 14.09, so it's approximately 14.09. All right, and that's what you're going to do every time, and I'm just going to leave this, and we're going to finish up the next examples on the next video. I hope you understand how to do that. See you.